Hi everyone. As always, for today's lesson, or warm up, you can get it in Canvas, print it, or download it, and we will give you a chance to do it. Before going over it, pause the video here to give it a try. Just like check your understanding from last class. They really all are. Alrighty. So for number 1, state the appropriate hypotheses. Well, remember, it's always equal. Couple reminders here. These are always the same number. And then these should be the same, and they should be a parameter. So mu or p for us. And because it's a proportion, right here is the word proportion. That's how you know to put a p. If it said mean or average, then we would put a mu. And then we define the parameter right there. Let's just highlight that. Find the parameter. Here is the definition. You just want to make sure you put it in context. So P equals 0.84 means 84% of teens think highly of their mother, that the true proportion is equal to 0.84. Interpreting the P value, remember we have first if that's the null is true. In context. And then we always say probability of obtaining, and then here we have our sample results. And don't forget to include the or more. So you have to have a direction. Then, okay, and then we have the p-value right here. And then for our conclusion, what we do is we compare p-value to alpha. Then we either reject or fail to reject the null. And we reject when p is less than alpha, fail when p is greater than alpha, and then we either do or do not have convincing evidence. And we do when we reject, and we do not when we fail to reject. And we put it in context. So hopefully that is clear there. Here's number 1, then number 2, then number 3 out of those 3 steps. All right, so take a look at that in more detail if you need to, and then also get out the "Are you sure your teacher is a good free throw shooter?" And we will work on that. Isn't a good free throw shooter, I forgot. Okay, so last class we investigated a simulation to determine if I was a good free throw shooter. But today I want to get a real p-value from a calculation with a normal curve and all of that. So we're going to do the same test as before, but the problem is every class that we did it with got a different p-value. And I would like to investigate this further because many of you said that I was exaggerating and I didn't feel good about that. So I want to let the math behind the whole process officially determine if I was exaggerating or not. So we're going to carry out the same one. Just really quickly, I'm going to remind you of what we had. The hypotheses were HO, null, P equals 0.8, HA, alternative. I was exaggerating, so it could be less than 0.8. Now, what I want to do is put each of these in context, just as a quick reminder. So here we have Mrs. P is an 80% shooter, free throw shooter specifically. And here we have Mrs. P is less than an 80% shooter, i.e. I'm exaggerating. But we'll see. So like I said, each class had found a different p-value because each dot plot had collected different sample results from the spinner. So I want you to just move forward away from the simulation, and we want to try to do this analytically instead of with an experiment. So work through the rest of the worksheet. Remember our material from sampling distributions, Unit 5. We did that in January. And then you can finish the whole thing, pause the video to do that, unpause so that we can debrief and talk about some important ideas. All right. So hopefully you guys were able to get through this pretty easily since a lot of the material was just review from our previous units. We basically went through the whole process of a significance test with all of the steps. Remember, we have a 4-step process for inference, and we did all the steps here. So I'm just going to start at the top, and then we'll show you how all the steps work, and you'll be able to see the complete thing at the end. So remember, we use that acronym P or PATH. So P was our parameter and our procedure. And I'm going to add now hypotheses to it with a P in the middle. I know it doesn't start with a P, but it's got a P in it, so we can put it there. And so our procedure name in this case is going to be a 1 sample, because there was 1 sample of 50 free throws. Z, because it's for proportion, and we're doing a test for P. So that's the name of this significance test right here. Then we have our null and alternative hypothesis. Those work the same as they did before. And then you want to define the parameter. The P is the percent free throw shooting, so I do have that explained there. Number 2, we use the normal distribution. These are our conditions. So 2A and B is the A. Remember, assumptions and conditions. And I typically also like to include the alpha as well, which we didn't in this problem, but in general. And we have the same 3. You know, we have our random condition, our 10% condition, and our large counts condition. And so I'm just going to underline those and then remind you about large counts, the name. Don't forget to say normal. And notice I do n times p is at least 10 and n times 1 minus p is at least 10. With intervals, I would be using the 32, the p hat. But for test, I do have the p. It's from my null. And so I'm just going to make that note. Use the p from the null. The way a significance test works is we assume that the null hypothesis is true the whole time. And so we use that for everything, and that's what our probabilities are based off of. And so we want to use that when we can. And we have it written right there, p equals 0.8, so we're going to use that wherever there's a p in our problem. Number 3, we calculated the mean and standard deviation of the sampling distribution of p hat. We already have that from before. We have normally distributed, mean, p, standard deviation, square p, 1 minus p over n. And we use that to do our statistical work here with this S. So I'll remind you about that. And so what we need in our statistical work is 2 things. We need something called the test statistic, which is just a z-score. And then we need a p-value. Well, I'm going to give myself some room here. So if you look at this formula for the test statistic, test statistic, it's just a z-score. So I'm going to write down z equals, and that 0.64 was our p hat. So p hat minus the 0.8 was the P from the null, and the 0.0566 was my standard deviation, which was square root P1 minus P over N. This should look very familiar. We actually did this exact formula in our sampling distributions unit, and it was just a z-score, and it's the same thing. Now it's called the test statistic because it's the value from our sample used to get us the z-score to test our hypotheses out. And so we call it a test statistic now, or the standardized test statistic, because it's a z-score, which is standardized. And then to get the p-value, we can use table A or normal CDF. And so I use table A there, but we'll show you how to do that if you forgot. So we're looking for our z-score of negative 2.83. Here's negative 2.80123. And then we got our p-value from there. Now what we have to do next is make sure that that's shaded the right way. So 0.64 on my normal curve is just shaded to the left from there, and so that's the value from table A. I do also want to show you how to use normal CDF from your calculator. So let me just pull that out really quickly, and we can use the calculator to show you how to do that. 1 second. Should have had it pulled up, but I didn't. Oh, I got 3 days left. Well, we'll continue. Gotta get these videos done in 3 days. Okay, so I want to clear this out. First thing you do is you hit second vars 2, and then I want to find the z-score or the p-value that goes with 0.64 or less. And so what that negative 1 E99 is just like negative infinity. And I'll make my upper the z-score of negative 2.83. Z-scores have a mean of 0, standard deviation of 1, so that's all I have to do, and then I hit paste, and I get 0.0023 just like table A told me. And this actually gives me more decimals even, but we typically round these to 4 decimals. So 0.0023. So I'll just show you that. We have our lower, in this case, negative infinity. Our upper was the z-score, our mu was 0, and our standard deviation was 1. And I do like to have a normal curve drawn for the z-scores, normal 0, 1. And that's that 2.83 that we got there. So then the last S is our summary sentence. So even though we've only done this with confidence intervals so far, we have the same steps to do for a test. And so remember, I did this in the warm-up today. We have 3 things to do. We have number 1, compare our p-value to our alpha level. We have number 2, fail to reject or reject the null. And number 3, whether we have evidence or not. And so 1, compare. 2, reject, fail to reject the null. And 3, what is 3? Conclusion. So we have evidence or no evidence. Of HA in context. And unfortunately, it's now officially proved, not proved, prove is the wrong word. We do officially have convincing evidence that I am less than 80% shooter. I was exaggerating, but maybe I can just practice a lot over the next several months and build my skills back up. So here's the 4-step process, spells out the word pass that we'll do for a significance test. And if you look at the next page here, we have a lot of that written down just in a more concise way. So I'm going to go ahead and label that as the 4 steps as well. P, A, S, S. A couple things about that that I want to show you before you pause the video to copy it all down is with this first one. You could have a less, I'm just going to use the highlight feature to do a couple of things. So if I have a less than sign, I'm going to shade my picture to the right. if I have a greater than sign, I'm going to shade it. Oops, I'm sorry. Less than is to the left, greater than is to the right. And then if I have not equal to, then I'm going to shade both. Could be either one. So that's called two-tailed. And what it means is you find p-value. Oops, my handwriting is really ugly right now. Let me zoom in for this. Find the p-value for one tail and then double it, which we'll do in the check your understanding. So you can try it on your own, and then I will show you in the check your understanding how that works. We use the same three conditions, random 10%, large counts. For the large counts, make sure you say approximately normal. That's always important. And that you're using the P from the null. It's also super important. And then we have our test statistic, our z-score. I do like you to add here the z-score curve. You don't need to do the original curve because that's too much work, but the z-score curve you could put on there. It's easy. And then we have table A, normal, or use normal CDF or table A to get the p-value, and our conclusions here. So a couple reminders about that. If we have a less than sign, then we reject, and there is evidence. If we have a greater than sign, then we fail to reject, and there is not sufficient evidence. So those are the only things that change. Everything else is kind of the same idea for those. And then, of course, it needs to be in context. All right, so I'll zoom out and now give you a chance to copy that down so that you can have a full set of notes. Try to check your understanding when you're finished. All right, so there's two check your understandings. One is the steps are all listed out, so hopefully you were able to follow along there. And so we have our HOHA. I'm going to stop writing on this. Hopefully you're getting used to it. Our conditions. Remember, we are using the P from the null hypothesis, 0.25, and then 1 minus P is 0.75 for that large counts check. Don't forget to always say approximately normal. What I like to do for the test statistic is I like to write the formula first, then fill it in, because that way I know what to put where. And then I will use normal CDF to get that p-value, and then conclude. So I'll give you a second to copy that down, pause this video so you make sure that you got it all. And then if you've already done the next one, you can go ahead and keep watching. If you haven't done it, pause here to try it with the 4-step process. All right, so on this A, this is what you'll be asked. Do these data provide convincing evidence? That means test. And then it'll say the word interval for an interval. So you'll start to get confused about when to do what, but that should help. And then this time they gave us an alpha of 0.10. It's usually 0.05, but they can tell you what they want it to be, and that's just what you use. Otherwise, just 0.5. So I'm going to label this stuff. We have P. Here are our assumptions and conditions and the alpha. Our S, we have our test statistic. Work. We have our, let me label that over here actually. This is our test statistic. I like to put the formula before, like I said, it makes it easier to fill it in. Our p-value. And then I do like this picture of the standard normal curve with the z-scores because it's easy to draw on there. And this is what I was talking about. Differs is not equal to sign for your HA. Not equal to doesn't provide a specific direction. So if I get a negative z-score, I'll shade towards the tail. But what I'm saying is it could also be that far in the positive direction. And so that could go over here. And so whenever we shade both tails for not equal to, it's two-tailed. You want to shade both. What I did, I'll show you in the calculator, was because I got a negative z-score, I did second vars 2. And for negatives, I leave the negative infinity, then I put my z-score at negative 1.617. Oops, 617. It's a z-score, so I leave that 0 and 1 there. And then paste. And that gets me the shaded region on the left, but a not equal to HA means that I'm talking about as extreme in either direction, on the left or the right. So I'm going to times it by 2 to add those two tails together. And I got 0.1059. So I show that work here, and I suggest you do too. And then 0.1059 is greater than 0.10. And so we fail to reject a null, and there's not evidence of the alternative. And then if you look at the last one, this isn't part of the 4-step process, it's just a secondary question. We got an interval, and it's 0.6033 to 0.7567. And so that does include the null, which means another further evidence that we failed to reject it. I can't reject a value that my interval shows is plausible. And so this leads us to fail to reject. It confirms the same thing I got in there. And I do want to add that the alpha level and the confidence level add to 1. I want to say when the alpha level and the confidence level add to 1, a test and interval make the same conclusion. When your HA is a not equal to sign, or if. If you think about that, that makes sense. If I have my interval is the middle from here to here, and my test is the outside. So those kind of support each other that way. All right, well, hopefully that, oops, I forgot to label the last S for our conclusion. There's our 4-step process. Hopefully that helps, and if not, just keep practicing, and we'll practice some more next class as well. Have a great day. Try your homework. See you next time.